In the diagram, points A, B, D, and C lie on the circle. CE is parallel to AB with E on the AD produced. Chords CB and AD intersect at F, and D2 is given as 50 degrees and C1 is given as 15 degrees. First question wants us to calculate A. There's three ways in which they do this, all are related. So let's go ahead and take a look at the value of what should E be. So if we look at D2, it is an exterior angle of the triangle ADE. Right. And we know that the exterior angle D2 must be equal to the sum of the two interior angles, which is going to be the C1 plus your E. Therefore, your E should be equals to D2 minus C1, and that's going to be 50 minus 15, which gives us 35 degrees. Now, if we look at the lines C, E, A, B, which are parallel to each other, and they have a line that's going through them. Let's use AE. Then we can see that E and A are alternative angles. So E is equals to A because they are alternative angles. Therefore, A should be equals to 35 degrees. Okay. Now, another way we can look at it is that we can say that D is equals to B, which is 50 degrees. And the reason being is that they are angles in the same segment. Right. And this would then allow us to calculate for the angle of C as a whole. Now, what we understand about C as a whole, again, let's do those two parallel lines and we draw our inverse over there. What we will do, or transverse, sorry, not inverse, transverse. What we will see there is that B is equals to C1 plus C2. Right. Reason being is that these are alternative angles. And we can calculate C2 as being B minus C1. So that's 50 minus 15, giving us 35 degrees. Now, if we go back to C2 with A, we will see that these are angles in the same segment. So they must be equal to each other. And that's another way we can solve for 8.1.1.